Here are 4 additional maths level trigonometry problems I'm going to solve for you in this short video. First one, we're going to solve this innocent looking thing here. Now, a common thing that people do with this is they spot that there are 3 terms and each term divides by cos x. So people divide the equation by cos x, which would leave just cos x here, not squared. Take away 1 equals 0. And whilst that's not wrong, it's not quite complete, as you'll see in a moment. Here's the correct way to solve this problem. First, recognise, which hopefully you do now, that cos squared x literally means cos x all squared. It's just a shorthand for that notation. And then think about this similar expression here. Something squared, take away that something equals 0. How do we solve that? Well, the correct way to solve that equation is to factorise an a out, and then you have what we call a zero product. A times the bracket equals 0, and therefore either a is 0 or the bracket, a minus 1, is 0, which leads us to a equals 1. So you get 2 solutions there, a equals 0 and a equals 1. If we bring that idea over here back to this one here, we note that we can factor out a cos x from these 2 terms. So let's take that out as a factor, and then we have a big bracket that contains cos x take away 1. And you'll hopefully spot that if you expand or distribute this, if you expand it out, you'll get this original equation up here. Now, the benefit of this, as I said before, if you just divide by cos x, you lose this bit here. All you'll have is cos x take away 1 equals 0, which is only half the story. So this zero product means that either cos x equals 0 or the bracket equals 0, which leads us to cos x equals 1, just like we had over here. Now, cos x equals 0, that's effectively from this cos x here, yields the first solution 90 degrees. And using the rule for cos, if you subtract 90 from 360, you get your secondary solution 270 degrees. And then we need to do the same thing for the other side of this equation, which is this. So thinking about cos x equals 1, shift cos both sides, leads us to x equals no degrees, and 360 minus that gives us our secondary solution over there, 360 degrees. So we actually have 4 solutions to the original problem, and just make sure that you underline those to show the examiner that you that those are your answers. Now, it's a really good idea. What I've forgotten to do here is to say that we're solving this equation for x in the range 0 to 360. I should have said that right at the beginning as part of the question, otherwise we wouldn't have known in which range to give to find answers. Now, assume that all of the problems in this video are all for this range of x values here, 0 to 360. So here's the next problem, solving 7 sin x equals minus 3 cos x. Now, it looks complicated until you know what to do. The trick with this one is to divide by cos x. Now, if you think back, I just told you not to do that. If you go all the way back to here, I told you that you weren't allowed to do that here. So why are we suddenly allowed to do it? Well, you weren't allowed to do it here because cos x equals 0, as we saw, is a solution to this equation. Whereas with this problem here, cos x equals 0 is not a solution, because if cos x was 0, sin x wouldn't be 0, and that would leave a non-zero left-hand side equals a 0 right-hand side of the equation. So we're allowed to do it here. You're not allowed to do it when you can just factor it out, as we could in the last one. So when you do that, using the identity, sin x over cos x equals tan x, it just shrinks to this simple equation. We can divide both sides by 7, and then shift tan to get our calculator value or principal value. Now, that's not in range. Again, we're solving this between 0 and 360 degrees. So with tan, nice and easy to get additional solutions for tan, you just add 180. And then add 180 again. And so really, to tell the examiner that we recognise there's only actually two answers here, maybe just underline the original one. So we've just got our two answers, which are our answers to the equation. Remember, you can check these by substituting them into the original equation on your calculator, and you should find that they're roughly equal. I say roughly equal because we've rounded to 1 dp, so this should be very close to the same value, both sides of this equation. Third one. This one's a common one that comes up. The first step people take, which you can't really blame them for, is they square root both sides. And they get these two as their answers. Because, of course, the square root of the left-hand side is sine x, and the square root of a quarter is a half. And that leads us to 30 degrees, and then the secondary value, 180 minus 30, is 150. But again, this is only half the story, because look what we've forgotten. The plus and minus. So let's start again. Let's square root properly so we get plus and minus a half. And now what we really effectively have is two equations but written in one line. Sin x equals plus and minus a half is two separate equations. Sin x equals a half and sin x equals minus a half. We solve those separately. So as we've already seen, the left-hand equation gives us 30 and 150. The right-hand equation, principal value is minus 30 degrees, but that's not in range because remember we're solving between 0 and 360, but that is our valid calculator answer. So we'll do 180 minus negative 30 to get our secondary value, and then we can take those two existing values, the minus 30 and the 210, and add 360 to those to get more. But if we add 360 to 210, we're going to go out of range. But if we add 360 to minus 30, we get 330 degrees, which is in range. And then we have our four answers. Now, just to imagine that graphically, here's a graph of y equals sine x. Sine x equals a half means we're effectively drawing a line across the graph at y equals a half. So, here. And that gives us clearly these two solutions which we found, 30 and 150. And then if we draw a line at minus a half, we're expecting two answers there as well. Now, last one. Some people will say this is the hardest. Maybe. It's only hard if you don't know what to do. So the problem with this one is we've got sine x's, we've actually got sine squared x, and we've got cos x's. So you're not going to be able to get anywhere with this until you've got the same trig ratio, either just sine or just cos. Now, the relationship between sine and cos is this one. Sine squared of x plus cos squared of x is 1. That is an identity, which is always true for all values of x. And we can rearrange that. You can't square root. Sometimes people try to square root the separate terms. But you can't square root separate terms in an equation. Because if you could, then Pythagoras' theorem would simplify to a plus b equals c, which is of course nonsense. So you can't write sin x plus cos x equals 1. That's wrong. It only works for the sum of the squares. Rearrange it to make sine squared x the subject. What we've effectively done is just taken away cos squared x from both sides of the equation. And then we can replace this sine squared x here with this expression instead. So 2 times that plus cos x plus 1 equals 0. So it's the same template equation. But in this bracket, instead of sine squared x, I'm going to write this thing here, 1 minus cos squared x. And then all you've got to do is expand that, simplify it. So, well, I'm going to move everything to the other side of the equation. I've done that because I don't like having a negative squared term. And notice that we've got a 2 and a 1, which are going to combine to give a 3, which becomes a minus 3 on the other side of the equation. Now we have this line here is a quadratic. We've got 2 times thing squared minus thing, take away 3. That's quadratic. And it's easier to work with a quadratic if we do a substitution. So I'm going to let a new variable, call it a, equal cos x. And therefore our quadratic becomes 0 equals 2a squared, take away a, take away 3. You can use a calculator or brute force to try and factorise that. It does factorise quite nicely. They usually do, by the way, these ones. When it's come from a trig equation, it usually factorises. And then again we have a 0 product, and we're used to dealing with these. Either 2a minus 3 equals 0, which gives a equals 3 over 2, or the other bracket equals 0, which gives us a equals minus 1. So if we undo our substitution now and bring our cos x back in place of a, we get cos x equals 3 over 2, which you'll find has no solutions. If you shift cos 3 over 2, you'll find it has no solutions. And if we shift cos minus 1, we get 180 degrees, and that's our only solution in the range 0 to 360. Thanks.